We start by creating a new workspace. We'll call this Linear Elasticity. And then we'll open it. The first thing we have to do is upload some geometry. I have some examples here. We'll take this one. There, now the tessellation is completed. Looks good to me. Let's create a new simulation. We're going to do a static simulation. And the first thing we need to do is generate a mesh. I'm going to put these to as coarse as possible, hit save, and generate. Now while that goes, I can handle a few other things. This is going to be a pretty complicated simulation, so I'm going to bump it up from 2 cores to 4 cores. And for material, the base here is steel, and the rest of the assembly, this is aluminum. So I'm going to specify per part materials. We're going to say aluminum for this part. And we're going to specify steel for the base. And I happen to know that this Young's modulus is a little too high for the grade of steel that I'm using, so I'm going to change it a little. Great. And now it looks like our mesh is finished, so I'm going to go back to mesh and take a quick look at it. Perfect. That looks about right to me. Looks pretty high density. Seems fine. Let's inspect the contacts. So we have 2 parts here, and we have to tell the solver what to do in those faces where the 2 parts touch each other. So let's look at the contacts that have been generated. So it seems right to me. You want to see as much blue as possible or as little red as possible when you're generating contacts. This looks good to me. But why is there a second contact? Okay. So there's something happening on the surface here. Let's take a quick look. There we go. So we've got this letter R here, and the center shape in the middle of it is its own separate face, and that should be in contact too. So I think it did the correct thing there. Let's move on to boundary conditions and create a fixed boundary condition. Let me go ahead and show everything. We'll create a fixed boundary condition here on the bottom surface. And then let's apply a force over here. Let's say on this face. Let's push in the z direction. Let's call it 100 newtons. And we're ready to kick off the simulation. Run 1. Okay, the simulation finished. Let's go ahead and look at the results. Displacement looks about right to me. We have this little slider here that allows us to change the gain on the displacement. And if that's not quite enough, this little box over here is actually text edit, so we can bump it up a lot. And there we go. That's way too much. Another thing we can do is look at, say, the von Mises stresses. And that seems reasonable to me. And if it's too blown out by high stress concentrations, you can always adjust using these sliders down here, so you can examine more of the dynamic range. Lastly, we can animate. And that's how you run a linear elasticity simulation using Feather.